MS Ramaiah University of Applied Sciences.
Hi students, let us discuss PSK scheme. The aim is study of phase shift keying. Phase shift keying PSK is widely used these days within a whole raft of radio communication systems. It is particularly well suited to the growing area of data communications. PSK phase shift keying enables data to be carried on a radio communication signal in a more efficient manner than frequency shift keying FSK and some other forms of modulation. With more forms of communication transferring from analog format to digital format, data communication is growing in importance, and along with it, the various forms of modulation that can be used to carry data. Phase shift keying is a digital modulation process which conveys data by changing or modulating the phase of a reference signal or the carrier wave. The modulation occurs by varying the sine and cosine inputs at a precise time. It is widely used for wireless LANs, RFID, and Bluetooth communication. Figure 9 shows binary phase shift keying BPSK. The apparatus required are Syntec 2156 and 2157 kit with power cords, digital oscilloscope, probes, connecting cords. The connection diagram is as shown. Figure 9.1 shows initial setup of kit. The procedure is connect these power supplies of Syntec 2156 and Syntec 2157, but do not turn on the power supplies until connections are made for this experiment. Make the connections as shown in figure 9.6. Switch on the power. On Syntec 2156, connect oscilloscope channel 1 to clock in and channel 2 to data in and observe the waveforms. On Syntec 2156, connect oscilloscope channel 1 to NRZ and channel 2 to output of modulator circuit on Syntec 2156 and observe the waveforms. Adjust the gain potentiometer of the modulator circuit on Syntec 2156 to adjust the amplitude of PSK waveform at output of modulator circuit on Syntec 2156. Now, on Syntec 2157, select carrier frequency selection switch to 1.6 MHz and connect oscilloscope channel 1 to input of PSK demodulator and connect channel 2 1 by 1 to output of double squaring circuit, output of PLL, output of divide by 4, observe the waveforms. On Syntec 2157, connect oscilloscope channel 1 to output of phase adjust and channel 2 to output of PSK demodulator and observe the waveforms. Set all toggle switch to 0 and compare the waveform. Now, vary the phase adjust potentiometer and observe its effects on the demodulated signal waveform. Note, if there is problem in setting the waveform with potentiometer, then toggle the switch given in PSK demodulator block 2 or 3 times to get the required waveform. Now connect oscilloscope channel 1 to PSK output of PSK demodulator on Syntec 2157 and connect channel 2 output of low pass filter on Syntec 2157 and observe the waveforms. Connect oscilloscope channel 1 to output of low pass filter on Syntec 2157, then connect channel 2 to output of comparator on Syntec 2157 and observe the waveforms. Now vary the reference voltage potentiometer of first comparator to generate desired data pattern. On Syntec 2156, connect oscilloscope channel 1 to NRZ and channel 2 to output of comparator on Syntec 2157 and observe the waveforms. Now try to match the LED sequence by once pressing the reset switch on Syntec 2156. Figure 9.7 shows PSK modulation waveforms. Figure 9.8 shows PSK modulation and demodulation waveforms.
Hi students, current experiment is phase shift keying, modulation and demodulation. For this experiment, we require 2156 2157 board. Syntec 2156 board contains different line coding schemes. We choose NRZL, and this is the carrier frequency 1.6 megahertz for the phase shift keying modulation we are choosing. From using the carrier modulators, we are multiplying the carrier signal and the data signal such that we are going to get the phase shift keying modulated signal. Then in Syntec 2157 we have phase shift keying demodulation circuit, that is PLL, low pass filter and comparator. Here we are going to get the back from serial to parallel converter. Whatever we have transmitted bits, we are getting back faithfully or not will be checked using these LEDs. And digital oscilloscope. This is digital oscilloscope. Main power switch of this digital oscilloscope is this one, and we have two channel this is a two channel oscilloscope, channel 1 and the channel 2. These are the magnitude adjusting knobs, and these are the horizontal position adjusting knobs, and this is the time scale adjusting knob. Connecting wire and probes for the digital oscilloscope. Now we are going to start the connections for the experiment. In Syntec 2156 I am connecting clock output to clock input, and then connecting data out to data in. Then I am connecting NRZL low to unipolar bipolar input, unipolar to the bipolar. Then output of the unipolar bipolar to the signal input. Carrier of 1.6 megahertz. Carrier of 1.6 megahertz is connected to the carrier input of carrier modulator. Carrier input of carrier modulator. And we can observe the phase shift keying PSK output in this circuit, in this pin. I am connecting output of PSK of that is 2156 to the other board 2157, input to the PLL, and I am making common ground connection between the two boards, that is 2156 and the 2157. Then output of the PLL is connected to the input of low pass filter, output of low pass filter is connected to the input of comparator, and output of the comparator circuit is connected to the data input of the serial to parallel converter. And clock recovery for the PSK and DPSK, this one is connected to the clock input of the serial to parallel converter, and we have a switch where we can choose the frequency between 160 kilohertz to 1.6 megahertz. Now I am setting it for the 1.6 megahertz since I chose 1.6 megahertz in 2156 board. Now the circuits are done, circuit connection is over. Now I have to connect the oscilloscope probes. connect probes for the channel 1 and channel 2. Connect the channel 1 probe to the clock data for clock signal and the negative to the ground. Connect the channel 2 to the NRZL modulation data scheme and to the ground. Now let us switch on the boards as well as digital oscilloscope. Now I am switching on the power supply of boards and also switching on the power button of digital oscilloscope. Now press the auto set button of the digital oscilloscope and also press the run and stop button. So now I could able to see the clock signal as well as the data what we are getting out of line coding scheme NRZL. After this we are going to connect the channel 2 to channel 2 to channel 2 to carrier signal. You can see the carrier here and negative to the ground. Now you again press the run and stop button and you can stop the auto set also, and you can again press the run and this one. Now you are observing a carrier wave of 1.9 megahertz sine wave is chosen as carrier signal, and once we multiply the carrier signal with the data signal which is converted from unipolar to the bipolar, we are going to get the PSK phase shift keying output. Now again you press the auto set button and run and stop button. Now you can observe the phase shift keying output, modulated output. The sine wave here shifting its phase from one level to the other, such by that operation we are going to see the abrupt change in the phase of the sine wave, this one and this one. Again this is the output of phase shift keying modulation scheme. Now I am removing the channel 2 digital oscilloscope probe from the output of the PSK modulation to the output of PLL, and the other one negative is connected to the ground. Now observe the waveform by setting the auto set as well as the run and stop button. Here by changing the scale you can observe in detail. Yeah, this is what we can see, the spikes of positive as well as the negative here according to the data format. Now I am connecting the channel 2 probe from output of the PLL to the output of the low pass filter and observe the waveform. Again press the auto set button and run and stop. Now you can see the output of the low pass filter. Then remove the channel 2 probe to the from the output of the low pass filter and connect it to the output of comparator, and the other one is negative is connected to the ground. Now again observe this is the demodulated output data stream. These are the waveforms need to be observed. After observing these waveforms, we can observe another point in this boards. These are the bits D1 to D7, D6 are the bits, and D7 is the framing bit we are considering here. Again, we need to receive, these are the bits transmitted, phase shift keying transmitted and demodulated. PSK demodulation is carried out in the 2157 board. So the transmitted bit and the received bit should be one and the same. Now let us set all the bits to 0, only I am transmitting the framing bit. So you can observe the corresponding framing bit in the receive 2157 board, that is D7 here. Again I am varying few bits, like I am switching on the D1 bit, D2 bit, D3 bit and D4 bit. You can see the corresponding LEDs glowing here for D1, D2, D3 and D4. So this phase shift keying modulation and demodulation is working perfectly, and we could able to transmit certain bits and receive those bits faithfully. This completes the experiment.
At MSR, you arc your imagination further.